Hi everyone, thanks for joining us today. My name is Amber Jacobson and we're at the Astrotech facility in Titusville, Florida, just outside of NASA's Kennedy Space Center. Behind me is TDRS-M, NASA's newest communication satellite, and we're giving you a behind-the-scenes look today in the clean room facility here and taking your questions. Like I said, TDRS is NASA's newest communication satellite. It supports about 40 different NASA missions, including missions like the Hubble Space Telescope or the International Space Station, providing critical communication services and allowing them to speak to the ground anytime they need to in their orbit. With me today is Paul Buchanan, who's our Deputy Project Manager for the TDRS project. How are you doing today, Paul?
Oh, I'm doing fine.
Awesome. So we're going to ask Paul a couple questions today. First one is, so TDRS, like I said, is a communication satellite. How does it play into NASA's overall mission?
Well, like you said, it provides scientific data, telemetry, video services, not just to the ISS, like you said, but to the Hubble Space Telescope. All the beautiful pictures that we've seen over the years, maybe close to a decade or more of the Hubble Space Telescope come through TDRS, and so it'll continue. Some of the other missions that TDRS supports at Goddard, or not just Goddard, but other NASA centers, but at Goddard at least, is the Landsat missions, EOS, Aura, and Aqua. But basically Earth observing satellites. A lot of the data with Earth observing and ISS is constant, continuous. And so that's what TDRS does, is provide constant communication and data from those type of missions down to White Sands, and then is sent to different science data centers around the United States.
Great. So TDRS arrived here a few weeks ago ahead of its August 3rd launch, just to do final preparations. What kind of preparations has the satellite been going through since it's been here?
Well, we arrived here on the 23rd of June at Titusville County Airport, or Tituscoco County Airport, transported on a C-17 from LAX to Tyco, and moved over here to Astrotech. Since then, we've been doing bus and payload functional tests since around the 23rd, 24th, propulsion functional tests after that, and we've just fueled the spacecraft here in the last week. So what you see here is a full spacecraft and tested. What we're doing here today and tomorrow is final closeouts of the spacecraft, putting some final blankets on, making sure everything is removed that needs to be removed before flight, or things that need to be installed before flight are going on today. We made to the launch vehicle adapter Friday. We encapsulate next Tuesday, transport to the pad on the 25th, do some more testing with the launch vehicle on the pad from the 25th on, and then the opening of the window is August 3rd at 9:02 a.m.
Great. So we took questions from the audience on Facebook. Okay. First question, Vince Marin is asking us about the life expectancy of TDRS-M. Can you talk to that a little bit?
The engineering design life for TDRS-M, but K&L as well, is 15 years. The engineering design life is 15 years. But like any engineering development or fabrication and assembly, there's always margin that you build in. So to the electronics or to the structures. So it'll last probably 20-25 years, but the design life's 15. Great.
So how is adding TDRS-M important to the overall fleet?
Well, there's the legacy spacecraft that TRW provided NASA in the earlier or mid-'80s through the end of the '80s, and they were launched on the shuttle, right? And so just like any spacecraft, any electronics, they eventually will fail. So to provide the continuous communication and data from the legacy spacecraft that have had to be retired, that's the replacement that we've had with KLM, is continuous, or providing that continuous communication through the space network to NASA missions.
Great. So our next question comes from Kiari Serm. What are some of the technology differences that M has that's different from what we've already launched?
Just the bandwidth or the throughput that the new satellites KNL and M have and will provide, which is a lot higher throughput and bandwidth than what was on the legacy spacecraft from TRW. Okay.
So we talked a little bit about some of the missions that TDRS supports. Easy question. Does TDRS support our astronauts aboard the International Space Station?
Obviously, yes. Yes.
Okay. So we know that space travel is going to be changing in the next couple of years, especially with commercial crew coming online. How is TDRS going to be supporting a spacecraft like Starliner or Dragon?
Well, they provide tracking services to ELVs, or expendable launch vehicles, and do the same thing with those missions as well. In the near future, probably 5-10 years, there'll be different types of technology in terms of tracking. Could be optical, it still could be RF, but just like anything, technology advances, and that's what NASA's here for, is technology advancement.
Definitely. So our next question comes from Duke Steele. He wants to know how long before TDRS-M is relaying images?
Well, after launch, let's say in August, we'll do some initial orbit testing with Boeing. That'll be concluded by the end of this year. The plan is everything goes well, which I'm sure it will, we'll hand over to the Space Network probably right up first of the year, probably around the end of January, and then they'll take it over, and they'll probably put it into service pretty quickly. They may do some testing in February, but I would say they'll probably put it into service, probably February of next year.
Right. So last question, how can folks tune in to watch the launch?
NASA TV, right?
Definitely.
NASA Select.
All right, so that'll do us for today. Thank you so much for tagging along. If you want to learn more about TDRS, visit us on the web at tdrs.gsfc.nasa.gov, or you can follow us on social media. You can reach us on Twitter at @NASA_TDRS or on Facebook at facebook.com/NASA.TDRS. Thanks so much. Have a great day.